In this video, we're going to talk about half-angle identities. We're going to look at the formulas and then do some examples. So first, just so you can see where sine of x over 2 comes from, I'm going to derive it for you. So if you recall the previous double angle identity, cosine 2 theta equals 1 minus 2 sine squared theta, we're going to start with that. We first want to try and get sine squared of theta by itself. So I'm going to move 2 sine squared theta over to this side, and then I'm going to move cosine of 2 theta over to the other side of my equation. So now I need to get rid of this 2, so I'm going to divide both sides by 2, and I'm going to get sine squared theta equals 1 minus cosine 2 theta divided by 2. Now I need to get rid of the square. So if I take the square root of both sides, I'm going to be left with sine theta equals plus and minus, because anytime we use the square root to cancel things out, we're always going to be left with a plus and minus. 1 minus cosine 2 theta over 2. But here I'm really looking for sine of theta divided by 2. Now I need to divide my angle by 2. So over here I also need to divide that angle by 2. And I'm going to be left with sine of theta divided by 2 equals plus and minus the square root of 1 minus, here my 2's will cancel, so I'll be left with 1 minus cosine theta divided by 2. And this is going to be our first half-angle identity for sine. So here are all of my half-angle identities. The other two forms of tan x over 2 can be derived by multiplying the numerator and denominator by either this equation or this equation, and that's going to give us these other two forms of tan x over 2 or theta over 2. Okay, so looking at our first example, we have tan of pi over 8. So very similar to what we did with the double angles, the sum and difference identities, is that we want to get this into something useful that we can locate on our unit circle. So I can rewrite this as the tangent of pi over 4 divided by 2. And this is going to give me my pi over 8. But I'm just going to rewrite it so I can use the pi over 4 from the unit circle. Okay, using my formula, I have plus and minus the square root of 1 minus cosine theta, which in this case my theta is pi over 4, divided by 1 plus cosine of pi over 4. Now I'm going to have plus and minus the square root of 1 minus cosine over 4. Looking at our unit circle is root 2 over 2 divided by 1 plus root 2 over 2. And simplifying this, I'm going to be left with plus and minus root 3 minus 2 root 2. All right, in this next example, we have sine 5 pi over 12, which is not on our unit circle. So as before, we need to think of radian measures that are on our unit circle. So here if we note that 5 pi over 12 times 2 equals 5 pi over 6, which is on our unit circle. So I can now rewrite this as sine of 5 pi over 6 divided by 2. And using our equation from the previous page, we're going to have plus and minus the square root of 1 minus cosine theta. Here our theta is 5 pi over 6 all over 2. So I'm going to have plus and minus square root 1 minus cosine of 5 pi over 6, which is negative root 3 over 2, all over 2. Okay, simplifying this, plus and minus square root. Since I have a 1 here, I'm going to get the common denominator, which is going to be 2, so I can rewrite my 1 as 2 over 2. I have minus a negative, so that's going to change into a plus, root 3 over 2, all over 2. Since I have my common denominator now, I can add these two together and get 2 plus root 3 over 2. Okay, now I want to get rid of this 2 in this denominator. So I can keep the first fraction, change it to multiplication, and then flip this one, which is going to make it 1/2. And now that it's multiplication, I can just multiply straight across. And I'm going to get 2 plus root 3 over 4. I can simplify this one more step further because what I really can do is separate the top and the bottom and get root 4 on the bottom. And root 4 is a perfect square, so I'm going to end up with plus and minus root 2 plus root 3 divided by 2. And that's going to be my final answer. Okay, in this last example, I wanted to show you again that we can still continue simplifying and manipulating trigonometric expressions as we get more formulas. So now that we have the formula for tangent of x over 2, I can now simplify this equation. I'm going to use the equation 1 minus cosine x over sine x. I chose to use this because I see it's being multiplied by a tangent. And I know tangent is sine of x over cosine of x. So I very kind of tricked you into randomly picking this, but the reason I randomly picked that was because I knew that I had tangent is sine over cosine. So in picking this, I was actually able to think 2 steps ahead and be able to see that my sines were going to cancel. And I still have that plus 1 over here. Don't want to forget that. So now this is going to simplify to 1 minus cosine of x over cosine of x plus 1. Now I'm going to change this 1 into cosine x over cosine x, so that way I can combine my two fractions. And that's going to give me 1 minus cosine x plus cosine x all over cosine x. Here my minus cosine x and my plus cosine x are going to cancel. And that's going to leave me with 1 over cosine x, which is just secant of x. So this whole equation actually simplifies down to secant of x. And that's all there is to half angle identities.